Welcome to this explainer covering Skip Uni's Lecture 17. We're jumping right in today to completely demystify C++ logical operators. If you've ever felt totally overwhelmed by those massive, interview-style Boolean expressions, well, you're in the right place. By the end of this session, we're going to conquer these concepts together, and you'll be handling them with absolute confidence.
Here is our roadmap for today. First, logical versus bitwise. Second, the core three operators. Third, practical code applications. Fourth, precedence and associativity. And fifth, solving complex expressions.
Section 1. Logical versus bitwise operators.
Okay, let's dive into this because this is a really common point of confusion, and it's exactly where the Skip Uni lecture kicks things off. There is a very strict boundary between these two concepts. On one hand, you have bitwise operators. Those operate at the absolute lowest level, literally taking raw data bits, like a binary 1010 and 0111, and comparing them bit by bit. But on the other hand, we have logical operators. This is what we're focusing on today. Logical operators do not care about individual bits. They work strictly with Boolean variables, meaning they evaluate entire conditions as clear-cut true or false realities.
Section 2. The core three operators. So now that we know what logical operators are, let's meet the big three heavy hitters in C++. First up is the logical AND. I want you to imagine a highly secure vault gate. This gate is incredibly strict and totally unforgiving. It only opens up if every single requirement is met. If you have 5 keys and even one of them is wrong, meaning a single condition evaluates to false, the whole result is false, and that gate stays shut. Both conditions absolutely must be true to get a true result.
In complete contrast to that, we have the logical OR. If AND is your super strict security guard, OR is the laid-back bouncer. It's highly relaxed and basically looking for any excuse to let you in. It just needs one single true to let you pass. You could literally have a dozen false conditions, but if just one happens to be true, the entire expression evaluates to true. The only possible way a logical OR outputs false is if every single condition it looks at is a flat-out false.
And finally, we have logical NOT. Think of this one as the ultimate flipper. It simply reverses whatever Boolean reality it bumps into. If a statement evaluates to true, applying a NOT instantly makes it false. And if it's false, NOT flips it right back to true. It seems simple, sure, but as we'll see in a minute, it packs a massive punch.
Section 3. Practical code applications.
All right, we've got the theory down, but why does this actually matter when you're sitting at your keyboard? Let's see how this plays out in real-world programming. Logical operators are the backbone of decision-making in standard if-else statements. Imagine a program trying to decide whether to execute a block of code based on 2 math conditions joined by our strict logical AND operator. And this brilliantly illustrates exactly how the logic works in practice. The program looks at the first condition. Is 10 less than 20? Yep, that's true. Then it checks the second. Is 10 greater than 15? Nope, that is false. Because we're using that unforgiving logical AND, combining a true and a false gives us a complete false. The strict requirement just wasn't met, so the program totally skips the if block and jumps straight over to the else.
Section 4. Precedence and associativity.
Understanding single operators is great, but what happens when they all show up at the exact same time? We need to know the rules of engagement. This is basically your must-know survival manual for coding exams. When a program reads a complex line of code, it doesn't just guess what to do first. Logical NOT holds supreme priority. It is the highest, and uniquely, it flows from right to left. After NOT, the strict logical AND takes second priority, moving left to right. Finally, the relaxed logical OR sits at the absolute bottom priority, also flowing left to right. You've got to memorize this order: NOT, then AND, then OR.
Section 5. Solving complex expressions. We are at the final boss battle of this explainer. We've built the foundation, we know the rules, and now we're ready to tackle something that looks incredibly intimidating. Imagine you're in a technical interview and they hand you this monster: true or false, and not false. At first glance, it's totally overwhelming. Your brain naturally wants to just read it like a sentence from left to right, but trust me, that will lead you straight into a trap. So let's take a deep breath. We aren't gonna guess. We just need to execute a predictable 3-step battle plan directly from that precedence table we just went over. Step 1, hunt down and resolve the highest priority operator, which is the NOT. Step 2, target the next highest, the AND. And step 3, clean up whatever is left using OR, moving neatly from left to right.
Now, what's really interesting here is how fast the chaos starts to shrink. Following our plan, we scan for the not operator. We find it at the very end, not false. The ultimate flipper does its job, immediately changing that false into a true. Suddenly, our updated expression is a whole lot cleaner. True or false and true.
Moving right along to step 2, we scan our updated expression for the AND operator, and there it is, right at the end again, false and true. Remember that strict security gate? Because one of those conditions is false, the strict AND forces that entire chunk to evaluate to false. Look at the expression now. It has dramatically simplified down to just true or false or false.
Let's move to step 3 and see how this builds to our final outcome. We literally only have OR operators left, which all share the exact same lowest priority. So our rule of associativity kicks in, meaning we evaluate straight from left to right. We grab that first segment, true or false. Because OR is relaxed and just needs a single true to pass, it evaluates to true. That leaves us with just one final piece of the puzzle, true or false.
And for that final segment, true or false once again evaluates to true. And just like that, the beast is slain. The final answer is true. By simply keeping your cool and applying strict rules of precedence, not, then and, then or, you just proved that you can systematically unmask and completely solve any complex C++ expression.
You now have the tools, the rules, and the confidence to handle logical operators like an absolute pro. But to really lock this in, I want to leave you with a bit of a challenge. I want you to apply your new battle plan to this practice question. What is the final result of false and true or not false? Trace the precedents, work through your 3 steps, and drop your final answer in the comments below. Keep practicing, keep coding, and I'll catch you in the next explainer.